Okay, students. In the last class, you studied about F block elements. You studied some properties of F block elements like electronic configuration and oxidation state. Now we will study the next property, that is atomic radius. See, uh, as we move across the lanthanide series, you notice that there is progressive decrease in the atomic and ionic radii of lanthanide series elements with increase in atomic number. So this regular decrease in the atomic and ionic radii of lanthanide series elements with increase in atomic number is called as lanthanide contraction. See, the definition of lanthanide contraction and causes of lanthanide contraction and its consequences are very important for exam. You must learn it well. See, what is lanthanide contraction? The regular decrease in atomic and ionic radii of lanthanide series elements with increase in atomic number is known as lanthanide contraction. What is the cause? What are the causes of lanthanide contraction? See, you have studied about atomic radius of D block elements. In D block elements, first the atomic radius decreases, then it remains constant, and then it increases. Whereas here, you notice that there is progressive decrease in the, there is regular decrease in the atomic and ionic radii. What is the reason for this? Say in D block elements, with increase in atomic number, first as the effective nuclear charge increases, the atomic radius decreases. Then next, the atomic radius increase in effective nuclear charge and the screening effect balance each other, compensate. So atomic radius remains constant. So here in F block elements, that is in lanthanides, with increase in atomic number, the effective nuclear charge increases. That is, as we move from one element to another element, the effective nuclear charge increases by 1 unit. So the atomic radius decreases. Now, the next, as the new electron is added to the same subshell, that is 4s subshell, 4f subshell. Here the added electron will be added to enter into the 4f subshell, same 4f subshell. Hence, the one more effect operate, that is the screening effect should operate. Here, the screening effect is ineffective. There is ineffective screening effect of F subshell. So since as the new electron is added into F subshell, there is imperfect shielding of one electron by the other in this subshell. In this subshell, the screening effect of 4F subshell is ineffective, that is imperfect shielding. So this imperfect shielding is unable to counterbalance the effect of increased nuclear charge. Hence, the net result is the decrease in size. So, the effective nuclear charge predominates over the effective nuclear charge. So, the net result is decrease in size. Hence, the atomic and ionic radii decreases with increase in atomic number in lanthanide series. That is, this is the reason for lanthanide contraction. Though this contraction, this decrease in atomic radius is less, it is very less. So we notice that here, we notice that the in lanthanides, the decrease in atomic radius for 14 elements, that is from cerium to lutetium, is only 11 picometer. And similarly, a decrease in ionic radii from Ce3 plus to Lu3 plus, that is for trivalent ions Ce3 plus to Lu lutetium 3 plus ions, it is only 17 picometer. So this is the reason for this is the cause for lanthanide contraction. Next, we will study about consequences of lanthanide contraction. What are the consequences of lanthanide contraction? So first consequence is, due to lanthanide contraction, the size of second and third transition series is same. That is, second and third transition elements are having same size, similar size due to lanthanide contraction. Example for this, one important example for this we can give is the atomic radius of zirconium and hafnium. Zirconium and hafnium, as you are seeing here, they have in zirconium and hafnium have same atomic radius due to lanthanide contraction. Zirconium atomic radius is 160 picometer and hafnium it is 159 picometer. That is, the atomic and ionic radii are quite similar. So this is due to lanthanide contraction. This is the consequence of lanthanide contraction. The next consequence is, due to lanthanide contraction, the electropositive character, that is basic character, gradually decreases from lanthanum 3 plus ion to lutetium 3 plus ion. Hence, lanthanum hydroxide LaOH thrice is most basic, while whereas lutetium LuOH thrice is least basic. So next one more consequence is, all the lanthanides have quite similar properties and are difficult to separate. So all lanthanide elements have almost similar properties, and since they have similar properties, it is difficult to separate them from each other. But due to lanthanide contraction, there is slight variation in the properties. Because of this slight variation in their properties, they can be separated. So they can be separated by ion exchange method, that is due to lanthanide contraction. So these are the consequences of lanthanide contraction. It is very important. Definition of lanthanide contraction, causes and consequences of lanthanide contraction, very important.